Assalamualaikum warahmatullahi wabarakatuh. We are from Group 15 in Section 2. Welcome to today's presentation of Steady-State Stability Analysis of Power System with Photovoltaic Integration. There are 7 things that we will explain in this presentation, which is Introduction, Problem Statement, Objective, Methodology, Results, Discussion and also Conclusions. There are 5 members in our group that will present their respective parts in this presentation. So, for the introduction, we will be presented by me, Muhammad Izzat Daniel bin Muhammad Isa, and my nomenclature is TE210117. So, for the introduction, this project aims to truly study and analyze the stability challenge associated with integrating PV system into the power grid. It involves assessing the impact of PV penetration on power system stability, identifying potential issues, and proposing innovative strategies and solutions to maintain system stability under various operating conditions. Accurate modeling of PV system and their control strategy will be crucial for capturing their dynamic behavior and understanding their impact on the overall power system. The IEEE 9-bus system model will be used for power flow analysis with photovoltaic distributed generation. Moving on to the problem statement. The increasing demand for electricity and concerns over greenhouse gas emission have driven the adoption of renewable energy sources, particularly photovoltaic or PV technology for distributed power generation. However, integrating PV system into the power grid poses unique challenge, including voltage fluctuations, reactive power imbalance, and potential instability, which can jeopardize the reliable and secure operation of the power system. To address this challenge, a comprehensive analysis of steady-state stability is required, considering factors such as voltage regulation, power factor control, reactive power compensation, and accurate modeling of PV system. The aim is to develop effective strategies and solutions to ensure power system stability during PV integration, enabling the successful deployment of clean and sustainable PV technology.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Oman bin Muhammad Safwan and my material number is TE210081. Okay, for now I will present my part, which is the objective. As you can see here, we have 4 objectives in this project, which is the first one is to model a test system model of power system using MATLAB. The second one, to perform load flow analysis. The third one is to analyze the system operating condition based on different level of load conditions. And the last one is to propose the ideas on how to mitigate power flow problems with the integration of photovoltaic distributed generation, PVDG.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Izzat bin Razali and my number metric is DE210084. And now I want to present about methodology. Okay, for the load flow analysis is an essential tool for power engineers to optimize power system operation and facilitate power trading. The choice of an appropriate and effective method for load flow analysis is crucial for ensuring an efficient operational power system. In this study, the Newton-Raphson method was employed in numerical form for power flow analysis using MATLAB simulation on IEE 9 bus test cases. The result indicates that the Newton-Raphson method converges faster, requires fewer iterations, and provide accurate power flow solution compared to other methods. Okay, for the Newton-Raphson method, the Newton-Raphson method is an iterative approach that approximates a set of non-linear simultaneous equations to linear simultaneous equations using Taylor's series expansions. It is a reliable method for load flow analysis as it can handle situations that may cause divergence with other methods and has powerful convergence characteristics. Alright, for the MATLAB software, MATLAB is a powerful programming platform tailored for engineers and scientists to analyze and design complex systems, making it well suited for implementing the Newton's reference method and performing load flow analysis computations.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Arif Ivan Khairuddin, engine number E210112. Okay, for the result for this project involves analyzing the impact of increasing the load at bus 8 in the IEE 9 bus system. The system consists of 9 buses, each of specific characteristics related to voltage, generation, and load. The primary focus is on observing the changes in the voltage magnitude and load values at bus 8 as the load is progressively increased by different percentage. The result indicate how the system parameters vary with respect to load variation. Okay, this is the result of increased load at bus 8. Okay, this is the bus data of IEE 9 bus system. And then this is the increased load. Okay, when the percentage raise, we can see the V bus 8 in PU unit is decreased, and the load megawatt and megawatt is increased. Okay, this is the coding. This is the result from the coding by using the MATLAB. And then what do we get from the result? Okay, increasing the load at bus 8 in the IEE 9 bus system result in a noticeable decrease in the voltage magnitude at the bus, indicating a higher voltage drop. This highlights the importance of considering load changes when analyzing system stability and voltage profile. And further studies could explore the impact on other buses and overall system performance. Okay, installation of photovoltaic system at bus 8 to attain either voltage magnitude. Okay, the project analyzed the effect of installing a photovoltaic PV system at bus 8 to achieve the desired ideal voltage magnitude in per unit. Okay, the result presented in table 6.3 include the PV capacity in megawatt, voltage magnitude at bus 8 in per unit, and load values in megawatt and megavar. The table demonstrates the outcomes after the PV system installation for various PV capacities. Okay, this is the result of the VVDG installation. Okay, if the photovoltaic megawatt is increased, okay, the V bus per unit is increased too, and we can see the load at bus 8 is same. Okay, this is the result that we get from the coding by using the MATLAB. Okay. Okay, what do we get? The analysis of the result shows that installing a PV system at bus 8 positively affect the achievement of the desired voltage magnitude. Increasing the PV capacity leads to a steady improvement in the voltage magnitude until reaching an optimal point at 100 capacity. Beyond that, there is no significant improvement. This finding indicates that the installation of a PV system improves the voltage the voltage magnitude towards the desired values, but further studies are needed to assess overall system performance and determine the most effective PV capacity while considering stability and operational constraint.
Okay, Assalamualaikum warahmatullahi wabarakatuh, and my name is Muhammad Akim Bisden. I batch number D10090, and I will talk about the discussion for this report. Okay, this section is focused on the methodology used to analyze and design strategies for improving full system stability, and this project is highlight the importance of advanced control strategies for PV inverter energy storage system coordination with other renewable source and advanced grid control technologies enhancing stability like solar and power grid system. Okay, discussion of increased load at bus 8. Okay, first we can see the V bus at V bus, which is PU voltage, PU power unit, which is the reading is decreased from 1 to 0.8, and the load is increased, which is the power in megawatt increased from 100 megawatt to 420 megawatt. This is the graph we get from the Excel, and this is the graph we can see from the high to low reading. Okay, after that, reverse over the Q, which is the megavar. Okay, the reverse is still decreasing the reading, and the megavar is also increase the reading. Okay, the reading is increased, and the graph is like this. Okay, what do we get? The power flow analysis using MATLAB software is a display in table 6.2 provide information on bus voltage. However, further increasing the load beyond 210% cause system instability. So the graph illustrates the relationship between power increase and voltage decrease. Okay, discussion of installation PVDG at bus 8. Okay, PVDG is the photovoltaic integration oscillator using MATLAB software, and this is PV photovoltaic installation. We can determine the real power value that will result the desired voltage per unit from initial real power of 550 megavolt and progressing to 100 megavolt. The experiment keeps the load power constant at 420 megavolt. Okay, here the graph for the V bus over the power megawatt, and this the graph which is the mega V bus is reading is increased from 0.8 to 0.9, and the megawatt megawatt is the stable, which is the constant at reading 420. Okay, this is the graph, and this is the V bus over Q, which is megawatt, and the reading for megawatt is constant, which is 147, and V bus is increasing from 0.8 to 0.9. And this is the graph we can get from the reading. We can see that the graph is increasing from another point to another point. Okay, what do we get from this part? Okay, we can find that the initial and intermediate real power output of 50 megawatt and 100 megawatt did not yield the desired voltage value at bus 8. However, the real power output is increased to 150, and the desired voltage value of 0.943 per unit successfully achieved. Okay, therefore, the photovoltaic installation at bus 8 is ensure the system operates within the desired voltage range and provide the necessary support for optimal power system condition. Okay, that's all from me. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Okay, now I will continue the next part, which is the conclusion. Okay, for the conclusion, in this project, MATLAB was used to simulate the IEEE 9 bus system and perform load flow analysis using the Newton-Raphson method. The analysis involves determining bus voltage, real power, and reactive power. By increasing the load and connecting a photovoltaic source, stable result were achieved with the photovoltaic capacity of 150 megawatt. This study addressed the challenge of meeting power demand and demonstrate the benefits of utilizing photovoltaic system for cleaner and advanced power generation. It also highlight the potential of other renewable energy sources. Integrating these technologies offers a promising solution for meeting power demand sustainability. Okay, that's all from me. Thank you very much, and Assalamualaikum warahmatullahi wabarakatuh.